Okay, so welcome back everyone. Today we will be solving Z code number 1161, maximum level sum of a binary tree. So let's see what the question asks. Given the root of a binary tree, the level of its root is 1. Okay, so we know that we are starting from the root and root's level is 1. The level of its children is 2 and so on. So it will go like this. In this example, let's say it is the root 1. So it is the level 1 and it goes beyond it. Once children is 7 and 0, their level is 2. Then seventh children is 7 and minus 8, the level is 3. It goes on like this. So this level will keep getting increased as the children's add up. So what we are asked is return the smallest level x such that the sum of all the values of nodes at level x is maximal. What does it mean? Let's see it by example. We need to return the smallest level x such that the sum of all the values of nodes at level x, at that level x is maximal. So what you need to do is, suppose we are considering this example and this is the level we are considering. This is the root node 1. It's considering level 1. And the total sum of this entire level of all the nodes summation is total sum equal to 1 because there is only one node in this level. So the total sum becomes 1. Let's go to the level 2. Once children are 7 and 0, this is the level 2. And if we add up, we are asked to sum all the nodes, sum of all the values of nodes at level x. So the level is now 2 and sum of all the values of level x is 7 plus 0 equal to total sum equal to 7. And again, 7 children is 7 minus 8, it becomes level 3. So in the level 3, the total sum becomes 7 plus minus 8, it becomes minus 1. So what we need to return is that the sum of all the values of nodes at level x is maximal. But we need to return the smallest level x. So what we need to return is not the total sums value. We need to return the level at which we achieved the total sums maximum value. So here in the level 1, the maximum value of total sum equal to 1. In the level 2, the total sums value is 7. In level 3, total sum equal to minus 1. So can you tell me in which level we achieved the maximum total sum? In level 2, right? That's why we have written max sum equal to 7 and which we have achieved at the level 2. So the output is 2 and that's why it's written here the output is 2. Got it? So what's the approach? You are seeing that we are traversing level by level and we are adding up all the nodes values in that level and then we are checking it. So we need a BFS traversal, right? Because BFS traversal goes like this, level by level. It's a level order traversal. So for each level, calculate the current sum. For each level, we are calculating the current sum. For this level, we have calculated the current sum, which is 1. For this level, we have calculated the current sum, which is 7. For this level also, we have calculated the current sum, which is 7 plus minus 8 equal to minus 1. So now what we are doing is, if current sum is greater than maximum sum, if the current sum is greater than already which I have got until now, the maximum sum, then only the current sum becomes the maximum sum. Otherwise, it won't, right? Because we have to consider a case where the current sum can be, where the current sum can be greater than equal to the maximum sum. Suppose in this level, the level 1, the total sum is 7, okay? And in the level 3 also, the total sum is 7. The level 2 is less. Let's suppose the total sum in the level 2 is 3. Here is 7, here is 7, here is 3. The competition is between these two. The total sum here is 7, the total sum here is 7. Then what we will return? We will return the smallest possible level. So in this level 1, we already achieved the maximum sum, which is 7. Then we don't need to go to the level 3 and just showcase that we have achieved that there. we have got it here. So only if we get greater than this maximum sum, then only we will consider this level. Otherwise, we will not. So we have written here only greater than. That's the constraint check here. We don't need to check greater than equal to. We only check greater than. Then only the maximum sum equal to current sum and answer level equal to current level. The answer level becomes the current level. And at the end, we can do current level plus plus so that the level keeps increasing. So the code will be simple if you are familiar with the tree traversals. So let's see. So if first we need to check if there is no root, then we need to simply return zero, right? Now, for tree traversal, what we take is, especially for BFS traversal in trees, we take queue data structure. So we took a queue and let's push the initial node at the queue, which is the root node, which we are given. And we need to take some variables. And for some variables, we will be needing maxsum. Let's initialize it with int min. Why we are initializing with int min? Because we can get all the nodes values as negatives, right? So if we get all the negatives, then if we initialize it by zero, then the negatives won't be considered, right? So if you take int min, then the negatives will be considered correctly. So take int min always, because we need to check the negative constraints also. And we need to take a variable as current level, and we need to take a variable as answer level, which we will initialize by 1. Now, uh, while the queue is not empty, n equal to queue dot size, take the size of the queue because we will be running a loop later on the queue, and we need to take a current sum variable. Yeah, we need to take a current sum variable, and let's initialize with 0. After initializing the current sum with 0, what we'll be needing to do is we need to run a loop on the queue. So we'll be running a for loop on the queue, and we will take each node of the queue dot front, and we will pop back that so that queue becomes empty, and we keep adding up to it. We will be seeing that it's a basic BFS traversal. You'll eventually know it. So now the operation we'll be performing is we will be increasing the current sum with the current node's value, right? That's what we are doing. In this level, we need to add up all the nodes values to the current sum, and then we will check it with the that it becomes the maximum sum or not. So we will be adding up all the nodes values to the current sum for this level. And now for the traversal, if node left exist, then we will be um, pushing the node left to the queue. If nodes right exist, then push the nodes right to the queue. Now, if what we need to check now is if the current sum is greater than the maximum sum. If the current sum is greater than the maximum sum, only and only if, then, only then, we can do maximum sum equal to what is our current sum right now. Because if the current sum is greater, then we need to convert the maximum sum to the current sum, assign the current sum to the maximum sum. And the answer level will be the current level. At the end, we will increase the current level. Now, it becomes a complete solution. At the end, we will return the answer level. Let's see if it works. Oh, extremely sorry, just minor errors. Uh, what happened? Wait. Okay, so extremely sorry for my mistake. The mistake was that we initialized the answer level with 1 and the current level with 0. We need to do the opposite of that. We will be initializing the current level with 1 and the answer level with 0. Okay, and now rest of the code is actually correct. I hope so. Let's run it. Okay, so it runs successfully and let's submit. Yeah, it's accepted. Time complexity. Let's analyze it for some fun. Let's we go in. We all know that the BFS traversals space complexity is good. Okay, so the problem is simple actually. If you know the how the tree traversals are done, if you are familiar with BFS, then it's just a piece of cake and it won't be rated medium for you if you have that idea. So yeah, that was about it. Farewell.